All right. We talked about lunar eclipses last time, and we saw some lunar eclipses and pictures. We saw some pictures of when they're going to be, some dates, when you can see them next. Today is solar eclipse day. So let's talk about solar eclipses, because that is what you need to see. Now, not all solar eclipses are spectacular. I'm going to talk first about some that are good, but there's one that you have to see if you haven't seen one yet. Most people have not. Well, to show you the circumstances for a solar eclipse, so let's title today Solar Eclipses. Solar eclipses. What I want to do is this. I want to show the Earth. Kind of making it big here. Calling it Earth. Let's show the equator. Show it tilted like this. That's pretty good. That's all right. Let's say here's north and here's south. And let's put the moon in here. And of course, the moon on this scale would not be this close. It would be far. But what I'm going to do, I'm going to put the moon over here. Make it a little too small, but that's okay. I'll just do this. It's about right size compared to the Earth. Moon. Now, what's going to happen is, let's say the sun's way far away. So what would happen is that and let's say it's a new moon, all right? So it's going to be blocking the sun. That's what we need for a solar eclipse. I'm going to show this. Let's show the umbra. All right? And let's show it dark. So let's say this is the moon's umbra from the sun, very dark region. So this is going to be very dark, total shadow. And let's say the umbral spot happens to be striking the Earth. That's what you want. So, but remember, if there's an umbra, what else is there going to be? There's going to be a penumbra. Well, let's show the penumbra. I'm going to do this. Should be kind of more of an oval. So remember, there's going to be the umbra at the center of this penumbra. So here's the penumbra. Now, let's talk about some places you can be. This is what you want. You want the umbra of the moon to strike the Earth. Doesn't happen very often. Maybe once every 2 years, or a year and a half, I should say. Well, then we'll have you write some things down. Because what's going to be happening is this is not going to be sitting there in the Earth, right? There's some things moving. What's moving? The Earth's moving. It's rotating. It's also moving in space, right? But the rotation is what really is going to cause the shadow to move a little bit. But the main thing that's moving here is the moon. The moon is going around the Earth, of course, it orbits the Earth, at 2,000 miles an hour. So we'll start the moon. If the moon's moving, the moon's shadow is going to be moving. So the moon moves at about 2,000 miles per hour. So what's going to be happening is this whole thing, the penumbra and the umbra are going to be moving at 2,000 miles an hour. Now, the umbral spot. Now, we're going to talk about this umbral spot in a second. But first of all, let's talk about the penumbra. The penumbra can be about 4,000 miles in diameter. You're more likely to be in the penumbra than the umbra. Remember, penumbra's big. Umbra's not. But if you're in the penumbra, if you are in the penumbra, which is more likely if you're seeing any eclipse at all, if you are in the penumbra, you would see what is called a partial solar. A partial solar eclipse. Partial. And how is that going to look? Well, the sun is way off in that direction. Here's how it's going to look. You're going to have the sun, and you're going to have the moon. Well, you won't see the moon, but it's going to be something like this. The moon will be like right here. What you'd see, if it's day, and it's going to be daytime if the sun's up. So you won't see the moon here. It's black. It's a new moon, so you're not going to see it. So you're going to have, but what, you know what you're going to see? The sun. But you're not going to see a full sun. You're going to see like a crescent sun, like that. The moon would be in front of the sun. You won't see the moon. So all you can do is look up there, and again, here's one thing that you have to do, is not look at the sun with your naked eye. You damage your eyes. So you need to get special eclipse glasses or a filter to see this, or make a projection with a pinhole, make it like a little pinhole, or look underneath a tree with all these leaves. So you get something like this, but you cannot look. If any part of the sun is visible, you cannot look. Do not look at the sun with your naked eye. You have to get some sort of special filter that has to be good. It can't just be a filter you make, unless you make filters for solar filters, but don't do that. Buy an approved solar filter, and you could see this crescent sun. Otherwise, you wouldn't be able to see it at all. If you're just walking around while they're in the penumbra, you'd say, nah, everything looks fine, even though it might be a little darker, but you wouldn't be able to tell that. Now, we'll come back to this in a second. I want to show you something else. I'm going to do the same kind of diagram, but I'm going to put the moon a little farther away. Here's Earth. Earth. North Pole, South Pole. Let's put the moon a little farther away in its orbit. A little farther away. Because remember, it changes in its orbit. It gets a little closer and farther from the Earth as it orbits. There's a perigee and apogee. Well, let's see what something else that could happen is this. Watch. Sometimes, because it's a little farther away, look, and of course, look what's striking here. It is not the umbra. Here's the umbra, because the moon's a little too far away. You know what would be striking the Earth? Look at this. What's that? What were we talking about last time? That's the antumbra, the region of transit. Now, of course, you're going to have your penumbra here. So, there, of course, there'd be this penumbra around here, right? But sometimes, if the moon's a little too far away, the umbra wouldn't even strike Earth. The antumbra would. So, if you happen to be the region of transit, or the antumbra, right? The region of transit, or the antumbra, you would see, well, you know how it would look? It would look like this. You'd have the sun. Again, here's how you view from Earth. Here's the sun. The problem is this. The moon's not big enough to block the whole thing. Here's the moon. The moon's a little smaller. That's moon right there. You notice something? The sun's apparently bigger than the moon. If the moon's a little too far away, the moon looks a little smaller. So you know what you see? Look at this. And again, you wouldn't see the moon. It's a new moon. You'd see a donut. A donut sun. Something like this. And you know what? Maybe not see that much sun. It'd be something maybe like this. Kind of like that. So you'd see a donut sun, and a donut shape is called an annulus. The shape of a donut. Think of like a Krispy Kreme original glaze shape. An annulus. You don't have to know that. Annulus. Doesn't mean like yearly. So you would see what is called, however, because it's called an annulus, a donut shape, and the sun looks like a donut, you would see it's called an annular solar eclipse. I don't know if you see that. Look, annular solar eclipse. Now I saw this once, and it was good, but again, you can't look at the sun with your naked eye. If there's any sun showing, you can't look. You need a filter. So I saw one of these once. I don't necessarily need to see one again. One's coming up, though. One's coming up in like Northern California a little bit, or Oregon. And I think a few years, I'm going to talk to you about that. If you want to go see one of these, I recommend seeing it. Again, don't look at the sun with your naked eye. Don't look at an eclipse with your naked eye. So that's an annular solar eclipse. That's good to know. If you're in the region of transit of the antumbra, you see an annular. We already said this. Look, If you're in the penumbra, you would see a partial. Now, let's come back to this. Here's where you really want to be. You have to be in the umbra. You have to have, I mean, if it's an annular eclipse happening, and like you don't have any choice. But if there's a total eclipse happening, it means you're going to have to get in the umbra to see it. So yeah, if there's a total eclipse going to happen somewhere on the Earth, it doesn't mean it's happening where you are. The chances are not. You're going to have to get to the umbra. You have to get yourself there. Now there's a problem. The problem is this. A couple of problems. The umbra is not very big. The umbral spot, remember I said the penumbra is about 4,000 miles in diameter? The umbral spot at max, that spot right there, at max, the umbral spot, you don't have to know this, is approximately 170 miles in diameter. Only 4,000 miles for the penumbra, 170 miles for that. So that means your odds of being in it are not that great. And plus, is it just sitting here? No, it's not. It's moving. The whole shadow is moving. Why is the whole shadow moving? Because the moon's moving. The moon's moving at 2,000 miles an hour. Well, guess what? If you're moving at 2,000 miles an hour, guess how fast your shadow's moving? Well, hopefully the same rate. So the moon's shadow is sweeping across the Earth at 2,000 miles an hour. But luckily, this spot, if the Earth is rotating, so the Earth is spinning this way, so the Earth is rotating this way. If this strikes near the equator, you're getting 1,000 miles an hour of Earth's motion. So here's something that's kind of nice about this. If this umbral spot, of the whole umbra, the whole shadow is moving at 2,000 miles an hour, but if you can move along with it at 1,000 miles an hour, that means you're making it move slower. And why would you want to make it move slower? That means if you're in it, the eclipse would last longer. The eclipse would last longer. So, under the best conditions, I'm going to write this down. If you are in the umbra, you would see I got some spaces. I'm going to move over here. A total solar eclipse. Look, if you're in the umbra, you would see a total solar eclipse. And I'm not going to even try to draw one. There's no way for someone who has seen a total solar eclipse to describe to someone else who hasn't seen one what a total solar eclipse is like. Yeah, I can describe what a partial is like. It's actually, my picture is almost as good as it is in the real sky for once. Yeah, it looks like that. Hey, can I describe a annular? Yeah, you guess what? It looks like that. Partials look like that. Annulars look like that. But totals, unless you see one, your eyes pick up things that even pictures can't give you. You cannot. And my dad always talked about this. I wish I could show this to you. I can't now. One of his favorite things, well, food was one of my dad's favorite things. Actually, it was his favorite thing. Food was more important than anything else. Desserts, I mean, pizza, bagels, everything. Oh, but he loved pie. I mean, apple pie. He just loved that with ice cream. He loved that. And he talked about, like, one point. I wish you could tell this to you. If you saw a picture of a Bavarian chocolate pie with whipped cream, and if you had one of these Bavarian chocolate pies, this cream pie, oh man, it's incredible. But what if you saw a picture of a Bavarian chocolate pie, and you had never seen one before? You had never tasted one before. Is that picture going to tell you a lot about the pie? You may not even know what you're seeing. So if you see a picture of a total solar eclipse, you know nothing about the eclipse. If you see a picture of the partial, yep, it works. You know about the eclipse. If you see a picture of an annular, yeah, you know about the eclipse. It's what it looks like. No one can show you a picture of an eclipse, a total solar eclipse, and have you know what it's like. You can't. There's no way, because what happens is it's not just the eclipse. And if you've seen one, you know what I'm talking about. There are things that happen around you on the earth when one of these happens. There's a feeling you get. There's a feeling everyone gets when you see a total solar eclipse. There are things you see with a total solar eclipse that a camera can't pick up. Your eyes pick up things that cameras can't. Usually they say a picture is worth 1,000 words. No. This time, no, it does not work in this case. So you have to see your own. So I'm not going to attempt to draw a total solar eclipse for you. I would be ruining it. It's like me showing you a picture of a total solar. Now I'm going to do that, but I don't want to ruin it for you. You might think you've seen an eclipse, but really you haven't, as my dad said at one point. So I want to talk about total solars, but this is just to lead up to this. You need to see one. I will give you extra credit. There's one coming up in 2024. I think it's in April of 2024, going through the U.S. I will give you extra credit if you see it. I will be generous with my extra credit. I will give you 5 points of extra credit if you see this eclipse in 2024. You need to get a picture, though. I want proof. I have at least evidence that you were there. I need to get a picture of someone who doesn't care as much about the eclipse, needs to take a picture of you with the eclipse. All right? I don't want you to waste your time taking pictures. I'll talk to you about that. Do not take pictures during a total solar eclipse. Do not do anything but look, because here's why I'm about to tell you. A total solar eclipse under the best conditions, if the umbra is striking, remember, what's going to happen is this. The umbra, let me get a color for this. The umbra is not just going to be sitting here. It's going to be moving. There is going to be a path that the umbra takes, and you have to get yourself along this path. It's called the path of totality. The path of totality. I don't know if you see that. Look. The path of totality. You need to get yourself somewhere along that path. And you need to get there before the eclipse happens. And people spend thousands of dollars doing this. People travel thousands of miles to do this. There are eclipse chasers. They're also called ecliptomaniacs. There are people that once they see a total solar eclipse, they're not satisfied unless they see another one. And then when they see another one, they have to see another one. They're addicted. And once you see one, you're going to know what I'm talking about. You have to see another. And I'm going to try to describe that to you in a PowerPoint I'm going to show you. But again, the pictures I show you will not do this justice. I cannot. This is one time I cannot show you a picture and give you any idea of what it's like. But you need to get yourself along this path of totality. And remember, here's the path of totality right there. So you need to get yourself along this before the eclipse happens. And the maximum time you can be in this, if under the best circumstances, if the moon is a little closer to Earth or at its perigee, if the shadow, the path of totality is moving close to the equator, if the shadow is moving along the equator, the maximum duration, I'm going to write this down. Here's something I'd like you to know. The maximum duration for a total solar eclipse equals, I'm going to write it here, 7 minutes and 40 seconds. If you're on a particular spot on Earth, look, that's as long as you can see a total for. I don't think it's ever happened. The best I've heard of is like 6 minutes or so, just over 6 minutes. I saw a one in 1991 that was about 6 minutes. Usually, they're about 3 minutes. There was one in 2017 through Oregon and up into Idaho, Wyoming. That was about, it was like a little less than 2 minutes. And that's kind of like typical, 2 minutes, 3 minutes. So if you're going to see one of these, and you only have, let's say, 2 or 3 minutes to see, you're never going to get one that long, but I'd like you to know that number. 7 minutes and 40 seconds is the max. That's not long. Well, you better be watching the eclipse. You better be paying attention. You better have your focus, not dealing with cameras, because that is the way to appreciate one of these. So we're going to see a PowerPoint slide show a little bit, and I kind of feel bad showing this to you, and for the next time, because it doesn't do it justice. I'll show you again. I'll show you a partial. Looks like it. I'll show you And annular, it looks like it. Totals, no, you got to see your own. In 2024, you'll get a chance. Maybe even earlier if you want to travel. So that is it. I'm going to turn this off. Oh, I'll have my wife, Megan, turn this off. It's easier.